Често се случва добрите QA специалисти да станат програмисти, но има и случаи за обратното. Следващият ни лектор започва своята кариера като програмист, но скоро се насочва по пътеката на софтуерното тестване. Дългогодишен ръководител на QA екипи в Beologic и Microsoft, той идва тук при нас специално от Копенхаген, Дания, за да ни говори за тестване базирано на модели. Дами и господа, ladies and gentlemen, Niels Christensen.
Thank you. Can you hear me? Okay, good. My name is Niels Christensen. I work for Milestone as a principal test engineer. Principal just means that I get to do this in addition to being a normal QA member in an agile team. My goal with this presentation is that you go away with two new tools that you know are there and that you know how to use, or at least that it will be relatively easy for you to start using them if you end up in a situation where you think they would be useful. First, a question: how many of you do regularly write code? Yes, okay. How many of you do occasionally write code? Okay, a few more then. Good. I'm going to talk about two tools. One is does require some coding, and a lot of the presentation is going to be about how little coding is actually required to do this. And I'm also going to mention a different tool that doesn't require any coding, but is useful in a lot of cases. It's so simple to use that I'm not going to dig into any details there. Okay. When I have to look into some new stuff, I prefer to start out with the real-life problem that it's supposed to solve, instead of, for instance, having a lot of theory first and then go to the examples. So I'll start with the example. Oops. That's basically the first 4 slides. That's the setup. Then I'll introduce the problem and how I entered at model-based testing as a relevant solution for this problem. I'll then dig into some details of this model-based testing, mention other related tools. That's the tool that doesn't require any coding as one of them. And then I'll go into some detail on how to actually hook up the model-based testing to an automation framework. How much code is actually required there, and how complex is that code also. And I'll finish off with a few notes on validations and some results. But let's go to the setup. As I mentioned, I'm working at Milestone. We make video surveillance software. Basically, people sit there and look at a lot of screens. There's a good chance that the software that controls this is Milestone. The difference, what we deliver, in addition to what you get if you buy a camera, is that we can actually handle a lot of cameras. We have some recording servers that the cameras hook up to. We have a management client that allows you to manage all these cameras, define, okay, what resolution should there be? Should they only record on motion? Are there other rules? When should things get archived, and all that kind of stuff? For big systems, this is not it's not that simple. So that's basically why we're here. The smart client is where we display the data, either live data, or we can go back and see old recordings and find out what they do or what happened. The feature is that we were implementing is a very simple one. We want to move hardware from one recorder to another. It looks simple, but there's actually quite a lot of setup on one on the camera, and we want that to kind of be moved to the other recorder. It's stored on the recorder, partially at least. the smart client. Here's a picture. There's a web version on it out in the hallway. You might have seen that. There's a let me see. There's a live tab here. So these picture, if this was a running installation, they would show live pictures. There's a different tab, the playback tab. This is where you can see historical data, and you have a timeline down here. Right now, it's kind of stalled, and you can then decide. You can click play, and then it will start playing back some historical data. On this page, you can also mark a time frame and say this particular piece in time, these pictures here, this video in this time frame, I want to log that as evidence to be used in a court or for other purposes. I'm describing this because we'll come back to that later. The problem we ran into was that occasionally our new feature seemed to make the system crash, and it was sometimes hard to reproduce. I guess a lot of you can relate to that. Our first approach was to use our test automation and repeat some simple flows a lot of times. So we just moved the hardware using the wizard for it 100 times or so. That would actually produce some crashes. We could investigate those, get some dumps, and the devs were able to fix them. We did something similar without the UI. That's the here. This was the one where we would move hardware while it was playing back in the smart client, and we would start and stop the recording server and then look for crashes. We also repeated that several hundred times and got that to run stable. We had some 6 to 8 different crashes and got those solved. However, I was a bit worried at this point in time because yes, we had these crashes. I'm only testing 2 very simple scenarios. What about all the rest? And what is relevant? What is the rest? It's basically what about other flows and additional factors? If we move while recording, move while we're watching in the smart client, move while we're watching old recordings, where we have that covered up there, but still, how about if we play recordings from the old recorder after we moved it to a new one, and so on. So there are several scenarios that are relevant to test. So I started trying to list those and describe them in a simple way. Basically, it's relevant whether the smart client is closed or running. It's relevant which recording server the hardware is on. It can be on one or the other, on the third one. It's relevant whether recording is ongoing or not. It's relevant what's happening in the smart client. Are we seeing live? Are we seeing? Are we actually doing some playback of some historical data, or are we just on the playback tab? And finally, do we have these evidence logs in some of the data that we are looking at? Once I had this, I realized that there's a lot of combinations there, 72 combinations, and you can, if you look in some math and some stuff, find out that there are actually 504 transitions between each of the combinations of states. So that's a lot to test, and that's where model-based testing comes in handy. So that's why I started looking into it. Yeah. In addition to the states, we need some actions. If we are going into some model-based stuff, for the smart client, the actions are quite simple. You can start it, you can stop it. For the hardware being on one of the recorders, the actions are quite simple. You can move it to one, you can move it to the other, you can move it to the third one. Recording, yeah, okay, you can start recording, stop recording. Quite simple actually. It's not any big secrets here. For the smart client display, there's it's again simple. You can go to live, go to the playback tab, and go to the playback tab while it's actually playing something back. There's a condition over here. You can see it only makes sense when the smart client is actually running. So we have to have we have to be in the running state up here. Similarly with the evidence logs, you can add it or you can delete the log. But the smart client has to be running, and it has to be on one of the playback tab, because that's where you set them. That's only 12 actions, which is a lot, but feasible. What we have been through now is basically the model description, and in order to use a tool, you typically have to implement this this model in some way. I knew a tool from earlier, something that's called NModel, and that can work with a model implementation in C#. You then basically create one DLL with the model, and the tool can take that and generate test cases. That's the key thing about model-based testing. It goes one step further than automated testing. Automated testing brings you one step further from manual testing. Model-based testing doesn't only run the tests, it can actually generate the tests also. So this is the key thing. If you want this to actually run the tests and not only generate the test cases, you need an interface to some test automation, if you have that. And in that interface, or in that test automation framework you typically have a test case there. That test case would basically ask the tool over here to generate the test cases and run them, and it will then use the interface to actually run the tests. Yes. In general, the implementation depends on the tool. I choose NModel, as I mentioned, because I knew it from earlier. It's simple to use. It's open source. What it can do is it can generate test cases that visit each state of combination and take each transition at least once. So there were 72 combinations of states. If I have this tool generate test cases, it will make sure that all of these states are hit. It will also make sure that all the relevant of these 504 transitions will actually be exercised. And I'd be able to list all the 72 combinations, but I'm not sure I would be able to easily catch all the 504 transitions. Okay, as I mentioned, the model is implemented as a C# project, and I'm not going to show you how that's done, how that looks. And my aim here is to convince you that it's simple. So we'll see. Okay. How many of you are familiar with C#? Well, at least some of you. Basically, I define an enumerated type for each of our states. We have the recording server. It can have one out of 3 values. It represents with the server that the hardware is on. We have recording. It could be ongoing and stopped. Smart client has these 2 states and so on. Then I define 5 variables that each hold the current state. So it's not difficult. There isn't even. It's quite simple, this code. On top of this, I need the actions. So here I have an action: move hardware to recording server 1. And the only thing it does, it takes this parameter that holds the current recording server and says, okay, now I want this to have the value server 1 because it represents that the hardware is on server 1. Quite simple. there were also some conditions, and they are then they have to follow this format where it says enabled behind the name of this one, and there you can put in some condition. Basically, I don't want to move the hardware to recording server 1 if it's already there. Again, a relatively simple syntax. You do this for the 12 actions, add these additional conditions that I mentioned for some of them, with like the smart client had to be running before we could go on the tab and so on. And that's about it. So now let's look at what the tool does. It's a command line tool, so it's very simple, old-time fashioned. It takes a parameter file. I point at the DLL that I created with this code in. I say, okay, I just put in some big numbers there, and then I run the command line tool, and it will tell me, yes, you have 72 states. We knew that. It says 384 transitions. That's less than the 504, and that's because there were some conditions on some of the actions, and that basically reduces the number of transitions that are possible. And it can find out that this is 384 that are left, and that's nice. It can do some more stuff, like telling something about dead states and unsafe states, but I won't go into any detail with that. Oops. There's a different command line tool part of it that will generate the test cases. Again, it takes this DLL as a parameter, and then I have to tell them which file I want the test listed in, and it will generate the test case. It will look like this. There's a test suite. It consists of test cases. In this case, it's only one. And you can see the actions. So start the smart client, move hardware to recording server 1, go to the playing tab, but don't start playing anything, move the hardware to recording server 1, and so on and so forth. A long list, 384 steps. The results, well, all 72 states can be reached and will be reached if you run this test case. Yeah, oops. Here we go. We already talked about the transitions, and the way it lays it out is it creates one test case that has all these 384 steps, which is a nice thing. Sometimes you have situations where you have to go down into one area, and then you have to either start all over or do something else to get down into another area, which basically means that you have to take some steps to get back, and then you can go into some other states. So you end up with more steps in your test cases than there are transitions that you have to cover. But in this case, you can cover them all with exactly the number of transitions that were there. Yes. At this point, I'll kind of take a step back from this specific case and mention some other tools. One is Spec Explorer. That's a newer version, basically, of NModel. However, it's a plugin to Visual Studio, and it doesn't work on Visual Studio 2012 or newer. So it's some quite old versions that it works on. This also tells me that that there isn't a huge uptake of model-based testing, and I hope that this will make it at least a little more popular, because it is a very, very powerful tool if you are in the right, if you have the problems for it. The other tool is something that's called PICT. It does some pairwise testing. Have any of you heard about pairwise testing? Yeah, a few hands here and there. That's nice. What it does is that it reduces the number of combinations to test by only targeting all pairwise combinations instead of all combinations. In this case, we had, well, at least you got a preview. In this case, we had 72 combinations. If I only target all pairwise combinations, I can get that down to 10 combinations. Obviously, this is a nice thing if you have to do this manually. It does require that, or it's useful, especially if you don't have any kind of flows between the states, but just can just have to cover all combinations. That can easily run up into an impractical number of tests. So this is a way to actually make sure that you have a broad, solid coverage. Definitely not a complete, but a solid coverage. This is a tool that I won't go into any details with, because, as I mentioned, you can install it, and once you've installed it, a small manual will pop up, and it's easy to use. Good. Now back to the code, to the model-based testing with the NModel. What does it look like when we have to connect this application with some automation code? I kind of assume that you already have, or that one has a test automation framework where you can have test cases, and in that framework you would create an ordinary test case that basically would call the tool, ask a tool to generate test cases, and then the tool would use the interface to this one over here to run all the tests. That's what we did. How complex is this code? Well, there are these 5 things you need to implement. A stepper, which is the relatively most complex part. You need to have some kind of reset if you have more than one test case. The actions need to be implemented somehow. There's some setup, and there's some validation. I'll go into some details with the stepper and with the validation, because that's the interesting part in my opinion. This is the stepper, and that's basically the tool gives you an action to execute. In this case, it's the one I've listed is move hardware to recording server 1. Then I have a class here that's the interface class, and it knows how to make the test automation run this one. So I just call this method, and that will then go into the test automation and actually make the real system move the hardware. So I have 12 cases like this in this class. After I've done my action, my transition, I will check. I will call this function, which does some checking, some validation, and that of course depends on your problem, what you want to validate. And then there's the reset and another class that just has to be there. But it's quite simple code. It's not something that's difficult for anyone to write, if they know a bit of coding, of course. The validation in general, well, we were looking for crashes, so the only thing that we actually tested in this was we would run through each of our recorders and look for crashes on them. We would look in if there were any dump files created. We would look in the event log, and we also had some internal logs. So this method here would go in there and check, are there any signs that we had a crash on the box. If there's a sign of that, we'd count it, and then we would assert and basically throw an error and say, okay, we have a crash. Let's stop executing the test. Again, quite simple code. Two more comments on validation. It takes some coding to do the validation, and the more complex the validation is, the more coding. So you want to reduce that, as always. One advice would be to ignore flow breaking failures. They break the flow, which means that the test doesn't go any further, and it'll stop. You will notice, so you don't have to write any specific code for that. On the other hand, there might be failures that that doesn't break the flow, and those you might wanna write some validation code for. I have some examples. This is our add hardware wizard. Like many wizards, it has some steps that it goes through. You can go back and next. And in this case, you can see it's failed, and the next button isn't enabled. So when the test tries to continue and click the next button, it will fail because it can't. So there's no need to do any specific special coding for that. The next one down here, also a wizard. That's actually our move hardware wizard. It's actually done. You can close it and go on, but it failed. So in this case, the flow goes on, and you wouldn't have noticed that there was actually a failure. This you would consider coding adding some verification in the code to check for this. Yes. Results. Well, it took around 6 weeks to implement this, including finding and learning the tool. I want to thank Benze and Rune, two of my colleagues, for actually having implemented a lot of this. So far, we run it approximately 300 times. It takes about 71 minutes to run, excluding the setup, basically installing everything on clean boxes and things like that. It's found 3 bugs, not much, but still relevant bugs. The issues we have seen when doing this is first and foremost stability. And stability of the feature is an issue. On the other hand, that's good because that's what we set out to actually look for. So any issue we find there, that's a bonus, that's a bug. We also had problems with our test automation stability, and that's of course not so good. You want your framework to be really solid and only stop executing tests when there's a problem and not because of some framework issue. The latest use, well, 2 weeks ago, somebody came from support. They had run into a problem, and our devs looked at it and said, "Yeah, okay, that's actually something we want to look for in our logs." And I said, "Yes, well, we have this test. We can just build in a check for that error and run the test and see if we can reproduce it." The problem was, of course, we couldn't reproduce it from the beginning. We didn't have any way of reproducing. They just happened to run into it, one of our customers. So then it's nice to have a system like this that actually can probe a relatively big part of the related code automatically. Yes. Now I'm actually close to the end. So I want to see, I have a few links here. A link to NModel, as mentioned, it's an open source tool. You can download the code and everything. You don't have to do anything. There's a book that goes with it. I have it up here also if anyone wants to have a look at it afterwards. There's also some links to PICT, this pairwise testing tool. It's again open source. You can download it. This is a direct link to an MSI file, so it'll just download it. You can install, and as I mentioned, the user manual will pop up as the install stops. So if you have, for instance, a setup where you have to test several operating systems, several browsers, several languages, and so on, and then you think, oh, okay, it explodes, then you can use this tool, get a huge reduction in the number of test cases that you actually have, and you will then have at least pairwise coverage of your area. Questions? Yes.
Hello there, and congratulations for the lecture, because this is a topic that it's not very oftenly discussed. And happily, it's probably one of my favorites, model-based testing and WISE. Because I noticed that in one of your slides, you were using actions, but they were looking more like events. So this is like a bug that I found in one of your lectures slides.
I'd say that.
Do you agree with the comment?
I agree to the extent that some call it actions, some call it events. It's
well,
the same
it's
thing.
actually because we can have them both at the same time. So action can be the representation of the state transitioning when it happens. So this is the thing that you're using for the validation. Yeah. But you know that just
I know that.
Also regarding the picked, because you said that you can reduce to 10, but it's only important if you run it manually. It's not that a problem when you run it automatically.
Yeah, that was. I'd agree. It's not only important when you run it manually. Also, when you run it automatically, it's important to reduce the number of test cases.
And you can do tree-wise, not pair-wise, and it will be pretty much the same as running all of those 72. It will be like 20 combinations, but it will do pretty much the same job.
If you do what?
If you do tree-wise,
yes,
it will achieve at least 97% coverage, and you will reduce your testing 3 times.
Yeah. I worked for Microsoft for some years, and they looked into this and because to see how many of the bugs do we actually find when we reduced and test only 10 instead of the 72 combinations, and they found that they found almost all bugs. They found very many bugs.
Above 95.
Only even if they reduced to 10 combinations, because the bugs were typically depending on only 2 of the
parameters.
States. Yeah.
Yes.
So that's why I'd say go for 2 first. If you have more time and resources, then you might go for 3 or even more.
And also another thing, I didn't get what's the purpose of the NModel, or how the NModel understands how to run all of the combinations, is this N switch? I mean coverage, like all of the 580 something?
It will run. It will make sure that it covers all these 384 tests, and it can actually run them to the interfaces that I've shown. So
it uses the class as an input?
Yes.
Okay.
It uses this model DLL that I showed as input, and based on that, it will generate all the test case and can actually run them.
Okay, I had another question, but I can't remember it now. So
No.
that was
anyone else with a question? You get it. Yeah, we have one down there at the back. Yes.
Yes, my question is, basically, I got the impression that the test case that is generated is a long list of transitions, so several hundred ones.
Yes.
So suppose at the middle of this test there is some bug. How do you identify what caused it? Because it's probably could be dependent on just the previous transition, or maybe on something that happened 100 transitions before that. I'm not sure. It's basically, how do you debug and find out how to reproduce the bug afterwards?
Well, you have several options. You can look at the specific state you were in and the last action you took. You can try that out then and see does this produce an error. You can also run the whole suite again and see does it does it reproduce and at the exact same time. That may not actually be the case. What we do when we run into a bug, and in this case that would be this assert, is that we actually stop the test execution, and we have the boxes. We can go in on them. We can find the dumps and analyze those, and that way find out what's actually wrong. But there is, you're completely right. There is some work in finding out what actually triggered this error.
So thank you once more, and
Thank you.
it was a pleasure for me.